This is asking us to find AB, or A times B, given these two matrices. Matrix multiplication is a fairly unique operation. So a certain condition has to be met before we are even able to multiply the matrices, and that is that the number of columns of A has to be equal to the number of rows of B. So kind of an easy way to look at that is just determine the size of each matrix. So A is a 2 by 2 matrix, and B is also a 2 by 2 matrix. And then we're looking for these two numbers here having to match up. Okay, so those are both 2's in this case, so we can proceed with the multiplication. Now the size of our product, or our answer, is going to be a 2 by 2 matrix because of these outer two dimensions. Okay, so as we set this up, A times B, that's our matrix A, times matrix B. To get each of the entries in our product, we have to use one of the rows of A and one of the columns of B. So to get our entry here in our product in the first row and first column, so we call it the 1, 1 entry, I'm going to use the first row of A and the first column of B. And I'm going to multiply the corresponding pieces and then add those together. So our 1, 1 entry here, I'm using the first row of A, so the first entry there is a 1. I'm going to multiply it by the first entry in the first column of B, which is a 4. So I'm going to do 1 times 4 plus 3 times 1. Now that's going to give us 7. So that's the number that goes in our 1, 1 entry. Okay, just moving to the right there, we're still in the first row, but now the second column. So that tells me to use the first row of A with the second column of B, so the 6, 0 column. So my first row of A, I'm still going to use a 1 there, times 6 plus a 3 times 0. And that'll give me 6. Okay, and then we have essentially run out of columns of B, so now we need to bump down to our second row of A and go back to the first column of B. So it'll give us our 2, 1 entry. So using the second row of A, get 2 times 4 plus 5 times 1. So that makes 13. And then finally, using the second row of A and the second column of B, will give us our last entry. So that's 2 times 6 plus 5 times 0. So that's 12. Now one thing you can notice, and kind of to make sure that you set up all your multiplication correctly, is in these first two lines here of our computation, we have 1's here and 3's here. Those are coming from the two entries in the first row of A. And then on the second two lines here we have 2's and 5's. Those are the numbers in the second row of A. And if we look at the numbers in parentheses, we have 4, 1, that's the first column of B. 4, 1 down here as well, and then 6, 0, and 6, 0, that's the second column of B. So we should have that type of pattern anytime we're doing this kind of multiplication. So our solution here is this 2 by 2 matrix made up of those entries that we got by carrying out these operations.